So, all right. So this is the second part of today's topics. It's gonna be about modular arithmetics. Okay. I'm gonna go a little bit fast. We might not be able to cover everything, but we work on. So let's look at the problem 3. Look at the problem 3 in the exercise. We will learn how to solve it. Problem 3. So it's a linear system, but it's gonna be the variable will be integers. Okay, modulo something. So don't try to solve it now. You don't know how to do it, but you will learn how to do that. Okay. So so let's get started. Okay, so I'm gonna skip over all the quick check because we don't have time. Okay, let me remind you again. Last time when we talked about, like today, when we talk about problem size, okay, when I told you about Euclidean algorithms that it runs in polynomial terms, we have the concept of problem size. Okay, if you want to sort n numbers, the problem size is like n, the number of numbers. If you have a graph, the size is going to be the number of vertex and the edges in the graph, like the maps. If you have matrices, then you have n square numbers. So the size of the problem is n square. But if you just have two integers, okay, the problem size is either 2, that is a constant. So the only algorithm that runs in polynomial time when the input size is constant is the algorithm that runs in constant time. That doesn't work for us. So we use the number of bits in this case. So if you have two integers, the problem size will be the number of binary digits. Also, if you want to check if n is a prime number, the input we have is going to be just one number, right? So the problem size cannot be 1. Otherwise, the algorithm cannot, have us needs to run in constant time. That doesn't work for us. So the problem size that we use will be the number of bits in the numbers. So the problem size will be log of n. Okay. To find GCD, the problem size will be the log of a plus the log of b. And then if the running time will be like for add two integers, the running time will be log of x plus log of y. So that will be polynomial times. Like polynomial times, like the algorithm run efficiently. You will learn about it in algorithm course next semester. Okay. So I'm gonna go really briefly on that. Okay. All right. So let's get started with modular arithmetics. Modular arithmetic is like you can think about it. An example of that when you think about days. Okay. So what day is it today? It's Monday, right? Sorry. This is from another course. So I assume that it's Thursday. Okay. So what day is it tomorrow? Like after today, 3 days after today. So let's say today is Monday. So what day is 3 days after today? Monday, Tuesday, Thursday, Friday. No. Tuesday, Wednesday, Thursday. It's gonna be Thursday, right? Monday. Okay. And then what day is 20 days after today? So then you have, if today is Monday, it's Thursday, like you have like Monday, Tuesday, Thursday, Friday, Sunday, and then you come back to Monday, right? So the numbers like go over itself over and over again. So this is like, if you think about number in this way, it's like it roll back to the first number, right? So this is like, when we think about modular arithmetic, it's this way. Okay. Also, you can think about it as clock. So if it's 1 o'clock, what time is the next 5 hours? It's going to be 6 o'clock, right? How about next 10 hours? 11 o'clock. But if 20 hours, let's come back to 9 o'clock. So the numbers like go back, it's roll over and then go over again. So This is like when you think about modular arithmetics, you perform like all the arithmetic operation, and then you just think about it in terms of like this window of the modulus. Okay. So this is called modular arithmetics. Okay. So when you do the RSA algorithm, we do everything modulo some number, right? So when working with modular arithmetics, we need to start with the modulus. So the modulus m is a number that we use to modulo everything that we do. Okay. When you add two numbers after you've done the additions, you modulo the result with the modulus. Okay. So we can define our arithmetic operation modulo m. Suppose m is 7. When we think about 4 plus 5, it's 9, right? But it's also equals to 2. Or if you define 3 times 4, that's 12. And then we mod m and we get to 5. You can do it with subtraction as well. So 2 minus 6 is 4, 4 mod 7. But what exactly is 4 mod 7, minus 4 mod 7? It's not minus 4, it's going to be 3, okay? So when you take the modulo of the negative number, it will be a little bit confusing. So it's going to be 0 minus 7, 7, right? So if you have 4, 4 is here. So 4 mod 7 is going to be 4 because this is a remainder. But minus 4, no, sorry, minus 4 exactly, minus 4. Minus 4. So minus 4, the remainder of dividing minus 4 with 7. So you divide minus 4 with 7, you get the result will be minus 1. So this is the result. And the remainder is 3. So remainder has to be like what is left. Okay, so minus 4 mod 7 is 3. Yeah. Because modular arithmetic is like you roll over, right? So you start with 0 or minus 7 or minus 14, and everything that you measure is like the remainder after the modulo. Okay, so this will be confusing at first, but you get used to it. Okay, so minus 4 mod 7 is gonna be 3, not minus 4. Okay, so we can define like if you modulo 7, like all these numbers will be the same, like 2, 9, 16, minus 5. Why is it the same? So let me draw it to you again. So if you do everything mod 7, so 0 is here, 7, minus 7, minus 14, 14, right? So 2 is this, 2, this is 9, this is minus 5, this is minus 12. So it's like, yeah. So think about a clock that has, a clock that has 7 hours, it will like go back, after 7 hours, go back to 0. Okay, so this is the same location of the hands of the clock. Okay, so when you have minus, it's like you shift down, so it has to be minus 7 or minus 5. Okay. Okay, so so we will define something like this. So when we do addition, if we work in modular arithmetics, when we do addition, after the addition we mod. When we do multiplication, after the multiplication we mod. When we do subtraction, after the subtraction we mod. That's it. Okay. Do you notice that there's one operation that I have left out? Plus minus times what else? Divisions. Okay, I'll come back to division soon because division will be something more interesting. Okay. All right. So I'll come back to this property later on, but we'll prove that A mod B equals going to be equal to B mod B, B mod M. Sorry, A mod M equals B mod M is and only if M divides A minus B. Before we prove that, so let me give you a proof, not a proof, but the idea of the proof as pictures. Okay? วาดรูปนิดนึงครับ so if you mod below M, okay, if you do everything mod M, so this is 0, this is M, this is 2M, this is 3M, this is minus M, minus 2M, minus 3M. So if you have two number, if A mod M equal B mod M, it's gonna be like this. So maybe this is A and B is this, right? Or let's say you have C mod M equals A mod M as well. So C might be this guy, and you can see that if the remainder after modding M with M is the same, it's like they differ in the multiple of M, right? So this is like 1, 2, okay. So this is like 2, they differ by 2 M's, and this one also differ by M, right? This one also differ by M, 2 M's, right? So if the mod, if every two numbers is the same modulo M, then the difference is divisible by M. Okay, we can prove it arithmetically, but if you think about this in terms of pictures, it's sort of like really clear. Okay, I'll come back to that later. This is the proof, but from the proof you might not feel like it's easy, but it's easy. Okay. We also have this. So if you add two numbers and mod, it's really the same that you mod and then add and then mod. So you can add the modulo operation anywhere in the process as you like. In the end, the result will be the same. This is why we can do the power modulo M really quickly, because we don't compute the actual powers. We compute the mod every time, so we keep the number small. Okay. Okay. So this is a new thing. Okay. When we have two numbers. Okay. So this is really important. I really hate to say A mod M equals B mod M. Okay. Because when we do modular arithmetics, we perform everything mod M. So we usually fix M. Okay. So we perform everything mod M. And if you need to write A mod M, B mod M, C mod M, everything mod M, you have mod M like everywhere, and it's really messy. Okay, so someone, I think he was Scout. His name was Scout. Invent this notation called congruence. So we write A congruence B mod M, which means A mod M equals B mod M. Okay, so basically, we will treat this, it's not the equal sign, okay? But when we work on it, we'll treat it pretty much like an equal sign. But we need to remember that, okay, everything we do, we mod M. Okay? When they say A equals B, it's not A equals B anymore. It's gonna be like A mod M equals B mod M. So you need to keep M in mind, okay? But we write it like that, okay? So also we have that if A congruent to B mod M, M divides A minus B. Okay. Sometimes if we are lazy, we might just write equals. But I'm trying not to do that because it's confusing. But I will not miss mod M. So when you see this, you know that A might not be equal to B, but they are equal modulo M. Okay? And the congruence works pretty much as you would expect from an equal sign. So basically, the number equals to itself, is congruent to itself. If A is congruent to B, B also congruent to A. And it has transitivity as well. If A congruent to B, B congruent to C, so A also congruent to C. Okay, so it works basically like an equal sign. So what it means by that is like if I know that if I have an equation like this, x plus 7 equals 5 mod 13, I can actually solve it. How do I solve this? So I just subtract 7, right? So to solve this, so I say x plus 7 subtract 7 equals 5 subtract 7, and that's minus 2. Okay? But what exactly is minus 2? Minus 2 is 11 mod 13. So x equals 11 mod 13. Okay, so you can plug it in. Like if you have x equals 11, if you add 7, you get what do you get? You get 18, right? Modulo 13, you get 5. But x doesn't have to be 11, right? X has to be 11 mod 13. So x can be, I don't know, 24. It can be 24. It can be minus 2. Okay. X can be many things. But if it's 11 minus mod 13, if you add 7 to it, you get 5 mod 13. So you can pretty much solve the equation almost. Okay. So the congruence is like everything that you know about equalities works. So you have two numbers, A equals B, C equals D. If you add them up, you get the same. If you subtract, you get the same. If you multiply, it be the same. Okay. So you can sort of like do everything except what is missing here. If you want to solve equations, you have 2x equals 7 mod 13. To do that, you need to divide 2, right? If you want to solve for x, you need to be able to get rid of the 2. Okay? And that's really hard because there's no divisions. Okay? So you need to be able to divide. But you cannot divide 7 by 2 because then you get some number which is not integers. We really love integers. Okay, if you divide 7 by 2, you get 3.5, and then it will be really bad for us. We want some integers. So that's what we will learn now. Okay. But the question is there any number that if you multiply by 2 is going to be equal to 7 mod 13? Is there any number that multiply by 2 and get to 7 mod 13? What is that? 20. 20 times 2, 40. 40 mod 13 is 7. Yeah, and I don't know. My calculator in my head is very bad. But there is, I can ensure that there is, okay? It's gonna be 49, I think. 49 mod 13. What is 49 mod 13? 10, exactly 10. You're right. It's gonna be 10. So how am I come up with that? So let me show you one trick, and we will come back to that. So I know that if this is equality. It's not equality. It's like it's almost like equalities, but you cannot divide, right? So if I multiply the whole thing, so I know that 6 is congruent to 6. Okay? If I multiply the whole thing with 6, what do I get? So I get 2x times 6 equals, no, 7. So, sorry. 7 equals 7, right? So if I multiply the whole thing with 7, 7 times 7 is going to be 49, and that's going to be 10 mod 13 because 13, 26, 9, right? So if you subtract 49, so if you do it one more time, it will be larger than 49. So the remainder is 10. But what is 7 times 2x? 7 times 2 is, what do you have? You have 14x, right? But what is 14? 14 is 1. 14 is 1 mod 13, right? So this is like x. 1 times x, and that's x. So I know that x is 10. How do you know it's 10? Hey, what's your name? Sorry. How do you know that it's 10? You just come up with your head. Wow, you're really smart. Yeah, it's 10. Okay. So if x is 10, this is true. Okay. You don't have x. You don't need x to be like 3.5 or something. If x is integer, it also works. But it doesn't work in all the cases. But in many cases that we are interested in, it works. Okay. But how can I come up with this? So my secret is this. My secret is this guy 7. I pick 7 not because it's not because that thing is 7. Okay. I pick 7 because, can you guess why I pick 7? If I use 7, right, when I multiply with 2, 7 times 2 is 14, but 14 is 1, modulo 13. Okay? So this number is like some magic. So if I would like to cancel 2, so if I multiply 7 with 2, I get to 1, right? So if I want to kill 2, so I have these equations. This equation is really bothering me because of 2, right? I want to find the value of x. I need to cancel out 2. But I cannot divide because there is no divisions. Okay? But I find a way to cancel 2 by come up with this magic number 7. Magic number 7 is good because it multiplies with 2 and leaves you with 1. Okay? So when you want to do divisions, you really need this number. Okay? But what exactly is this number? I'm not inventing something new, okay? Mathematician knows this for like 100 years. Maybe not, like seven, more than 100 years. Like 300 years. Okay? So this number is like the magic number. Okay? I'll come back to that. So you think of congruent as a normal operation, except you cannot divide. Okay. We would like to do the divisions, like when you want to say ax equals, if I know that ax equals xa equals xb mod m, I would like to cancel out x. Okay, but you cannot always do that. There are many cases when this thing doesn't work. Like for example, if you do thing mod 4, and you know that 2 times 1 is 2, like 2 times 3 is 6. But they are both 2 mod 4, right? But you cannot cancel out 2. Okay, so cancelling out is not always working. Okay, but sometimes it works. Okay. Okay, so sometimes it works. When it works like this. exactly like this. Okay, and this number 7. This number 7 has a name. Okay, but let me show you again. The property that we need is like 7 times 2 has to be 1 mod 13. Okay, 7 times 2 has to be 1. So it cancel out 2. Okay. Whatever does the initial 2 do to you, 7 will like reverse it because it gives you back 1. Okay? So what exactly is this number? So let's take a look at that. Okay? So let's take a look at that. So let's view multiplication as a function. So suppose I do multiplication by 2. Okay? And look at that mod 4. So when I do everything mod 4, the numbers that I need is gonna be 1, 2, 3, 1, 2, and 3. Okay. If you multiply with 2, what do I get? So multiplication is like a function. If I multiply everything by 2, 0 will go to 0, 1 will go to 2, 2 will go to 2 times 2 is 4, mod 4 is 0, 3 by, it's going to be this. Okay? So this is the function of multiplying by 2 mod 4. Okay? This function looks nice, but it has some problem. So if you have two numbers and I multiply by 2, right, it lands to the same guy. Okay? So now, if I know that there's a number that after multiplying with 2 is equal to 2, can I know which one it is? I don't know if it's 1 or it's 3, right? So solving equation in this case will be really hard because I don't know specifically which number is it from. Okay? Now let's take a look at that. If I multiply with 3, mod 4, let's keep mod 4. So let's do it again. Yeah. 0, 1, 2, 3. 0, 1, 2, 3. Now I multiply with 3, right? 0 go to 0, 1 go to 3. 2. 2 times 3 is 6. 6 modulo 4 is 2. 3 times 3 is 9. 9 mod 4 is this. Okay? Now, if I know that there's a number, if I know that 3x equals 2, now can I find x? Yes, you can find x because this graph has a really nice property, right? So when I want to solve this, okay, when I want to do, typically when you have this, you want to do divisions. คุณต้องการหารในเวลาเจอแบบนี้ we want to divide, right? But we actually don't want to do divisions. We don't want anything. We just want to find x. Okay? We want to find x. So if you look at this, we say this is a function that multiply by 3, right? So I know that there's some number that after multiply by 3 is 2. So it's gonna be 2. So that's x. I don't need division. Okay? Let's division go home. Okay? I only need to find what x is, right? So it doesn't work. I don't need division at all. Okay? But I can only do this when this function is nice. Okay? It's nice because for every number that I have on the right hand side, there is exactly one guy on the left hand side who points to it. So now I can go back, right? Multiplication is like takes you from this to that. Solving equation is like you want to go back. You want to reverse the operations. You want to reverse 3. If you work in real numbers, reversing is like division. You multiply by x, you divide by x, right? But for modular arithmetics, going back is not division. It's divisions, but it's the different kind of divisions. Okay, so when you want to go back, this is called an inverse. You know that something multiply by 3 get you to 1. You can go back to 3, right? So this is the inverse of this function. But this function doesn't have an inverse. Okay? So if your function has an inverse, you can solve equations. Okay? Now, okay, let's go over this really quickly before we do some practice. Let's go back. Forget about modular arithmetics. If you have standard arithmetics, you want to find out what is 2 over 5. How can you do that? What is 2 over 5? 0.4, right? It's 0.4. But what exactly is 0.4? We will think of it this way. So we want to find some number. When you want, what is 2 over 5? So it's basically, it's a number. So let's say x equal to 2 over 5, right? So now if I multiply everything with 5, so I get 5x equals 2. So finding 2 over 5 is like solving this equation. So I want to find some number after I multiply with 5, I get to 2, right? So how can I do that? When you are a kid, you just divide everything by 5, right? And then you get to the value of x. And this is like 2 over 5. You come back to the same thing, but it's stupid, but this is how it works. Okay? But if we do not have divisions, we will think of it this way. Instead of dividing by 5, we multiply the whole thing with 1 over 5. So 1 over 5, this is the notation that we have. 1 over 5 is like some rational number, right? So we multiply 2 with 1 over 5. So we start with this. So we start with 2 equals 5x, right? And we multiply everything with 1 over 5. Multiply 1 over 5. And you get 2 over 5. And this cancel out, right? 5 and 1 over 5 like sort of cancel out. This is the same thing as you multiply something and you get 1. Okay? Now you cancel out, so you have x, and you know x is 2 over 5. Okay? This 1 over 5, or what we write like 5 to the minus 1, this is referred to as the multiplicative inverse of 5. So 5 times 1 over 5 to the minus 1 get you back to 1, right? So now you know the value of x. And in real numbers, 1 over 5 is, what is it? It's like 0.2, right? So you multiply 2 with 0.2, you get 0.4, and that's the value of x. Okay? So this is for real numbers. Now, let's look at this in terms of modular arithmetics. Suppose the modulo is 7. Okay? Suppose you want to solve equation. If we do everything modulo 7, okay, then if you want to solve 5 in m equals 7, suppose I want to find x, 5x equals 2. What would I do? I need to find the multiplicative inverse of 5. So I need to find some number that I cannot divide, right? I need to find some number that multiplying on both sides, I get back x. So I want to find some number that after I multiply with 5, I get back 1. Okay? But what is that number? Modulo 7 is 3. Because 5 times 3 is 15, which is 1 mod 7, right? So I can multiply the whole thing with 3, and I get this to be 15x, and that's going to be x, right? And this is 6. So I know that x is 6. So 6 times 5 is 30, right? Mod 7 is 2. Okay? So I know that the multiplicative inverse of 5 modulo 7 is 3. Okay? So when you want to do divisions, again, there's no divisions, but we want to do it anyway, right? So there's no real divisions. You multiply with the inverse, multiplicative inverse. Okay? So if we want to solve these equations, we know that the multiplicative inverse of 5 is 3. So you multiply the whole thing with 3. So to multiply with multiplicative inverse of 5, which is 3, then you get to 6. And on the right hand side, multiplicative of 5 times 5 is 1, right? So you get x. So you know that x is 6. Okay? But how can we gonna be able to find the multiplicative inverse? We come back to that probably next time. But this is the definition. So if you stick with the modulo m, if you do everything modulo m, the multiplicative inverse of a, we denote by a to the minus 1. It's not going to be 1 over a in real numbers. Okay? This is just a notation. Okay? That you can think of as 1 over a, but not 1 over a. Okay? So this is the multiplicative inverse of a. We denote by this is an integer such that you multiply with a and you get 1. Okay? But how can we find it? I don't know. Okay, take your sheet of number. Take your exercise sheet. Correct. First problems. We'll do everything modulo 13. Modulo 13. If you do everything modulo 13, the numbers that you have will be from 1 or 0 to 12. 0 doesn't have multiplicative inverse. You cannot multiply 0 to get to 1, right? So 0 doesn't have inverse. So if you want to solve equation like 0x equals something, you cannot solve it exactly like in real numbers. But what is the multiplicative inverse of 1? Modulo 13, so it's going to be 1. What's the multiplicative inverse of 2 modulo 13? 7. Why? 2 times 7 is 14. 14 mod 13 is 1. So multiplicative inverse of 2 modulo 13 is 7. On the other hand, the multiplicative inverse of 7 modulo 13 is going to be 2. Right? Now, how about 3? It's getting hard. Okay? So let me help you. 9. 9. So why is it 9? 3 times 9 is 27, right? 27 mod 13 is 1. 9. Okay? So how are you going to come up with this? So let me show you the multiplication table modulo 13. Then use your eye to fill out this table. So for 2 it's easy, right? For 2 this is like 2, so it's this, so it's 7, right? For 3 it's 9 because 1 is here, right? For 4 can you locate 1? Here, right? So it's 10, right? The first row is multiplied by 1, so you can use it for closer around the index. So can you fill out this table really quickly? And now you can, after using this table, you can do divisions. You can do, I need to the quote unquote divisions. Okay? When you want to divide by something, you multiply by this multiplicative inverse instead. Now you can do Gaussian elimination. You can solve equations. Okay? So let's do some practice. So let me quickly, so I'll leave you with this, but let's look at the last question that we have. Okay, you should work on the third problem. After you fill out this form, this table, you should work on this problem. So basically, I ask you to solve these equations. So take your second to last digit, okay, and add 1. Suppose my digits is like 5. This will be 6, okay, and solve this equation. You can solve it like previously, like using Gaussian eliminations. But when you want to divide, what do? Every time you divide by some numbers, you multiply with its multiplicative inverse on that table. Suppose you want to divide by 7, you multiply by, I don't know, you multiply by 2. Okay? So, addition, subtraction, multiplication works modulo 13. Divisions, don't do divisions. When you want to divide, multiply with the multiplicative inverse. Okay? And solve this. Okay? So after you fill out the form, work on the problem 3. And that's it for today. Okay? เดี๋ยวทำเติมตารางเสร็จแก้สมการนี้แก้เหมือน Gaussian elimination ธรรมดาแต่ว่าเวลาหารก็คือเอา multiplicative inverse ไปคูณนะครับ So let me show you. Let's try to fill out this form and let me show you one example. Okay. So let's try to fill out this form. Okay. So 3, 4 is 10, right? 4 is 10. 10 is 4. What's the multiplicative inverse of 5? 5 is 8. So 8 is 5. Finally 6. 6 is probably itself. No, 11. Okay, 6 is 11. So 11 is 6. And 12. 12 is itself. Yeah, 12 is itself. Now you have this table. Okay? Let me show you how to solve one equation, simple equations. So suppose you have an equation like this, 2x plus 3y equals 6, and then x plus y equals 7 mod 13. So let me show you how we could solve it, okay? So to solve this, there are many ways to do that. I can subtract. This will be easy because it's an example, okay? So this is equation 1, this is equation 2. So I subtract 1 minus 2 times 2, right? So 2x minus 2x, x is gone. 3y, oh, too easy, sorry. Let's say, okay. So 2x minus 2x, x is gone. But 5y minus 2y, I get 3y equals 6 minus 7. 7 times 2 is 14, right? But 14 is 1, so 11 minus 1, so it will be 5 mod 13. Then I need to divide by 3, right? To get to y, I need to divide by 3, but I cannot divide. Okay, to divide by 3, I multiply the whole thing by 9. So I get 9 times 3. It's going to be 9 times 3 is going to be 27y. it's going to be 1y, right, equals 9 times 5, going to be 45. It's going to be 45 mod 13. What is that? 4, 3, 3, I don't know, 12. Not you can always use you can use console. Okay, so that's 6, right? So now I know that y equals 6. I can plug in, right? So I know that x plus 6 equals 7. So x is gonna be 1, and then so that's the solution. So y equals 6, x is equal 1 mod 13. Okay.